So right now our flames are combed upwards like this, and this is a great place to be because now we can basically go through, add some variety, and have an idea of what this baseline looks like. Let's go to SOPs in our PyroSimGeo and add a noise. So attrib noise. On the left-hand stream, this is our fuel points. Let's call this fuel noise molts. And let's make another attribute noise and call this one our fuel noise add. So what we'll do here is we'll multiply against these values, we'll cut into the values, and then we'll add another noise on top of that. Let's start by changing the mode here to multiply, the attributes to fuel. Down here at our visualization, let's change this from temperature to fuel so that we can see this. And I also want to change the distribution of points here. We just have a little bit too much fuel happening on the logs. So let's go back up here and change this. This is our logs. Turn that down a little bit on the logs. And then for the fuel on our embers, turn that up. So that now we have just something that's a little bit more equalized like that. Okay, so we have that. Let's now animate that by checking that box, remap so that we're working from 0 to 1, and then change our distribution so that we have more contrast like this. Also, with this distribution, I generally want most of the values leaning towards 1 when it comes to the fuel. I don't want this cutting in too drastically, and so by bringing this over, it's just going to prevent those cuts from happening too much. Let's take our pulse duration to about 1.5, element size to 0.05, so something really small. And now we have something like this, which is pretty cool. We want to control, I'd say, most of this variation through the temperature. And so with the fuel, the idea is just to add a little bit of variety. In the real world, I don't think the fuel would actually do this, although I guess technically if, like, let's say wind blows away the top layer of ash from a log, that could expose it to more fuel over time. So I guess going with that theory, let's pretend that we're trying to mimic that behavior. This element size, let's bring that, I think actually 0.05 is good. I want more detail, so let's bring up this roughness and this lacunarity a little bit. That'll just add a little bit more of the smaller features to this. And then let's take our pulse duration down to 1 so that we have this going on. And I think that that is looking pretty good. Just to check, let's do a flip book for about 2 seconds, so 60 frames, and see what that does. And yeah, I think something like this will work just fine. Let's now add another noise on top of this and create bigger features with it that are moving more slowly. So we'll stop that. Let's go now to our fuel noise add, change this to fuel, and go through the same sort of process again. So animate this, remap it so that now we're just adding a little bit, maybe a minimum of 0 and a maximum of 0.5. I think that would be a good idea. Let's also change this distribution so that we have contrast like this. And then I think that this layout is fine with the distribution. Let's just see what this does first. Pulse duration, let's bring this up to about 2. Element size, let's try 0.1. See what that does. And then I also don't want to make this too rough or have too much lacunarity. I just want a more general thing sweeping over time. So you can kind of see it down here in the ashes. If you pay attention to that zone, that is the values that we're adding. Let's go ahead and turn this element size to maybe something like 0.075, just a little bit smaller. And I think that'll work fine. Just to isolate this a bit more, let's bypass the other noise we just had. So now we just have the noise that's adding in. Let's do another flip book and see what this looks like. Okay, and I think I like what this is doing. Maybe let's just turn up the value a tad bit. It's maybe like 0.6. and then we can maybe change the distribution so that it airs more on the lower side of the whole spectrum. So let's try that out. We'll go here, do this, and say that we're trying to go to maybe like 0.6, like that. And then our pulse duration at 2, I think, is good. And yeah, I think that this will work just fine. Let's unbypass that so we have both of these noises. Do one more flip book. And there we go. That's our fuel. Now on to temperature. Let's do the same kind of thing. So we'll just make 2 copies of those nodes. And we will rename this to our temp noise mults and our temp noise add. Bring that right there. Let's create a copy of this visualization. We'll call this our fuel viz, and we'll call this our temp viz, and change these fields now to temperature. So same deal here. Let's now do the same kind of thing with temperature. With temperature, we can get away with a lot more because the temperature is not going to show up as obviously as fuel is when this goes to simulate. So we can be a bit more aggressive with how much variety is here, basically. Let's go to here, multiplicative, fuel, we want temperature instead. So temperature, let's change, our values are good. The only thing I'll change with this is the distribution. I want to cut in more, so I'll just bring that over, like so. The element size, let's keep this at a low size. I think that's nice. And then the pulse duration, I want to make this faster. So let's try 0.3, see what that does. Lacunarity, roughness, that's cool. Let's turn off this add for a second and see what this does for us. Okay, and I think that this really fast behavior is actually a good thing. It looks really sporadic right here, and if it ends up being too much, we can always change that later, but I want to try to get away with something really fast like this. So that's good. Let's now counterbalance some of that fast movement with a slower movement on this add noise. So maybe the pulse duration, instead of 2, can be about 1. Let's try that with this, and let's also err on adding more than subtracting. So we'll do this, and then for our element size, maybe make this a little bit larger, say 0.15. And see what this does. I think our element size should actually be 0.1. Okay, cool. I think that this is nice. I want to make one more change before we cache this out. So instead of going to 0 here in our distribution, I want it to go maybe like this so that it never actually reaches 0, but that it's more likely to still reach a low value, maybe like 0.1 or 0.2 when it multiplies. That way we still preserve some of that temperature and we don't have as much contrast, but we still have a lot of fast motion happening. Okay, so I think that this is all ready to go. Let's cache this out and see what this did for us within DOPS. All right, and check this out. Look at how much better those flames look. That made an enormous difference on the behavior, especially how the temperature oscillates, how it's going back and forth. That's what's causing these flames to kind of flick towards the end of its life. In my mind, this goes to prove that you don't need to totally rely on complicated microsolvers to get the majority of a fire effect. We're still at a very low resolution, and look at how much detail we're getting. It's great. Okay, let's now move on to some of these microsolvers and talk about the other things within our combustion tab. I think for right now, the source is looking fine, and we'll do that in the next video.